Let's get one thing out of the way. Windows is popular. And I mean very popular. It's honestly so iconic. The Windows background is nostalgia core. It was the first ever liminal space. The backrooms were definitely going for an everlasting Windows XP experience. Straight out of the womb, I was using Windows. If I could use it before I could talk, then that's pretty damn user-friendly. I mean, it's really straightforward and reliable. It's not trying to cater to corporate techie folk. Any generation can honestly get a gist of what's going on pretty quickly. Even to this day, Windows takes up nearly 3/4 of the entire market share. By far, I don't think I'm the only one that feels a sense of safety when I see Windows boot up.
How's it going, man?
Now it's time to tear that sense of safety down, because it's all a lie. Or is it even actually a lie? I mean, if you think about it, hackers shouldn't really care about Mac or Linux if hardly any users of the world actually use it. Isn't the real money destroying entire companies through a distributed system? Why would you even care to get through to a tiny percent of business users? In this video, I'll be focusing on the vulnerabilities of the Windows kernel. So the focus will be on the design of it. In the entire world of cybersecurity, this is only really scratching the surface. I will also compare Windows often with Linux to really demonstrate the design decisions of the Windows kernel.
I'm getting a little turned on right now.
The first most obvious thing that makes people feel safe in the Windows environment is knowing that some parts of your computer have admin privileges. And then, well, the rest of it doesn't, right? Some of the non-admin privileges might include the standard user, which do have some freedom but a lot of restrictions. Then there's guest privileges, which have a lot of high restrictions. A process that has certain restrictions is what you'd see in the Windows Task Manager. Honestly, this is another showcase of just how user-friendly Windows actually is. A low-level concept like process management is so easy to understand through the Windows GUI, which is the Task Manager. And just like Linux, a process is a running action that does some tasks. It's the same idea as me trying to bake a cake from a recipe. Programs are the written instructions in the recipe book, which are saved on your computer. And then processes put them into action using real-time system resources. So basically me actually baking the cake from the recipe book. If you think about it, the design is somewhat similar to Linux, at least on a basic level of kernel design. Each process has its own set of permissions, and each file that it tries to access also has its own rules and permissions. When they both line up to try to be able to access each other, then they can read, write, or execute as much as they're allowed to. And this is where Linux and Windows differ. Windows has user account control, or UAC. In Windows, each process can get its own access token, which dictates all of its permissions. And each file has a unique access control list, which is a list of users and system processes that dictate what they can do. The groups that you'll see in Windows are a lot less granular and more simplified than in Linux. For example, the administrators group have admin privileges across the board, and then some groups might have some specific privileges. They're way less flexible without having deep hierarchies of nested groups you might see in Linux. The way that Linux does this is honestly very similar to how Discord manages permissions and security. However, this makes Windows a lot easier to navigate.
It's a disability, mobility,
and understand as your regular computer user. But you can see quickly how this is a pretty major vulnerability. Historically, attackers have explored different ways to take advantage of this stuff. They've learned how to manipulate access tokens through methods such as token stealing and privilege escalation. Do you know how easy it is to fake privileges? Every process on Windows has an access token that you can duplicate. Then just assign that token to a different process and then bam. One illegal download that your grandma makes
before she died in a horrible way
means they have complete remote control over your entire system. Windows token exploits often target the core operating system, while Linux exploits frequently target misconfigurations, such as file permissions and using sudo, or vulnerabilities in specific applications or services. This is why it's so important when granting access on Windows, and to be careful not to spam chmod 777 on every file on Linux. However, Windows processes tend to be more vulnerable, since child processes in Windows often inherit all of the privileges of the parent process. In Linux, it's very limited and granular of how permissions get inherited by child processes, and it often sticks to a least privileges philosophy as it does this. Linux is definitely more complex complex to manipulate here, but it's definitely not impossible. If a hacker has access to sudo or something, or any administrator privileges of some kind, regardless of the type of machine, it will be devastating. Imagine we have a castle with a moat. Does it even matter what type of the design of the castle or how the moat is designed if the guards just leave the drawbridge open for 24/7? Most scenarios of compromised machines you'll find are just due to user error. You can make a Windows machine just as secure as Linux by simply making sure that everyone that uses it is mindful.
Very approachable, very demure, very natural, very approachable, very demure.
Windows traditionally had less robust mechanisms for process isolation and control compared to Linux. Windows relies more heavily on executable names for process identification, making it easier to deceive users, and some security mechanisms by modifying the displayed name. While both Linux and Windows use a PID or a process ID, and the PIDs are always determined dynamically and can never really be predicted, since Windows does sometimes use executable names to identify processes, it's much more possible to spoof a process, even really important system-reliant ones. Probably Windows' most vulnerable design flaw is its poor isolation. In Linux, you can go to the extreme of chroot jail, where you can isolate a process so much that it has its own file system, an own root, and it has no access to the host operating system's file system or its root directory. If you download something foreign or sketchy, you can always use this instead to fully isolate it to ensure the security of the process. In Linux, it's always recommended to avoid using system-wide changes as much as possible. This is something that is less emphasized in Windows and often harder to do, even though it is technically possible.
You can hire someone else.
System-wide changes can potentially lead to a compromised machine in the worst-case scenario. Another big factor is that it's open source. For Windows, the whole repository is just reliant on Microsoft employees, where Linux has the best engineers on the planet working on it since it's open source. Everyone is also constantly updated with all the changes and know exactly what those changes are since it's open source. For Windows, it's just one giant mystery. Where the Windows kernel is insecure, Linux might be better, but it's definitely not perfect. However, it's still worth considering for businesses to use Linux instead. Yes, it's very true that Windows is most vulnerable by simply just being popular, but theoretically, if Linux was just as popular, it would be more difficult to find vulnerabilities by its nature. Okay, let's stop roasting Windows for now.
Emotional damage.
I want to bring up an important point when it comes to security. You are as strong as the weakest person on your team. And honestly, Windows is the only platform that does an excellent job at making really low-level concepts extremely human readable. Think of it this way. I'm some boomer that doesn't even know what this magic box is doing 99% of the time. The task manager has an excellent way of showing me of what all of the actions and tasks that are happening behind the scenes. I mean, I honestly even understood what a task manager was when I was 4 years old. I would also pretty quickly understand what's meant by admin privileges and non-admin privileges just simply by the context. Now, I might not really understand what hacking is, and it might just seem like a big conspiracy theory, but at least if something seems sketchy, like system.exe, downloaded by a weird dark web website, I am way more likely to stop that from happening on Windows than any other platform, even if I have no idea what's going on. Maybe the best thing for the future of security is to design for the average person using it instead of developers or people who are tech savvy. Thanks for watching. I hope you learned something today.